Hi, today we are going to learn how binary search works in 2D space. Okay, so with this question, means question number 74, search a 2D matrix. With the help of this question, we are going to learn how you'll be solving this question, then how we are going to apply binary search in this particular question. Okay, let's read the question first. We'll keep on building intuition and at the end we're going to apply binary search. Okay, so what the question says, you are given a matrix m cross n, yeah, with the following properties. Each row is sorted in non-decreasing order. Got it? That is increasing order, means repetition is allowed. Okay. The first integer of each row is greater than the last integer of the previous row. Okay. If here you can see 7, then in next row, the first element will be greater than 7, that is 10. If you see 20, then next condition is it will be greater than 20, that is 23. Okay. Now what is given? Given an integer target, return true if target is in matrix or false otherwise. Okay. You must write solution in order of log of m cross n time complexity. Okay. So first let's understand how we are going to solve if we are given a 2D matrix and we need to search for an element. The first thing will come in your mind is iterate each element and see if that element is present in this particular 2D matrix or not, right? Let's say you are searching for 3. Then what you can do? You can check 1, you can check 3. 3 is there, so you will be returning 3. But what if in next question we need to search for 13? Is it present in that array? How we can solve that out? We can do one thing, like we check 13 one by one. Is it here? Is it here? No, no, no. Till 7. Check with 10, not equal. Check with 11, not equal. When you go to 16, it means that particular element is less than what you are searching. Means it is guaranteed that 13 will be not in this matrix. So in that case, you need to return false. Got it? Now, you know how to solve that problem in a linear order. How now we need to build intuition like how we can solve this problem in log of order of m cross n. Okay, so how we can do that? Let's get back to board and there we'll see how we can solve that out. Okay, so if you see here we have that matrix only, and now how we can we represent this matrix like 1 3 5 7. This is one matrix, and next is just after that element 11 16 20 and so on, right? So you can represent it like this. Now, is it possible ki can we create one index for each and that can be mapped to row and column? Like I wanted to say, is it possible to map this with 0 1 2 3 4 5 6 7? Can we map it, is the question right now. Let's say we wanted to know if we are at sixth index, then it will be referring to 16 only. How we can check that out? We can do one thing in original array. Let's say these are columns. Then we have 4 columns and 3 row, right? If you see, we represented it in a linear fashion. I'll linear fashion. What we can do if let's say we have n is equal to 6, then what we are going to do? If we divide it by number of column, like let's say we have 6, and if we divide 6 by n, let's say m cross n matrix, m is 3 and n is 4, right? Means 3 cross 4 matrix. What if we divide 6 by 4? We'll be getting 1. And what if we do 6 mod 4? What we will be getting? That will be 2, right? Means we got two number, that is 1 and 2. Is it like, can we represent this as a zeroth index, sorry, zeroth row? This will be first row. So we need to go to first row, and first row's second indexed element is 16, right? Because this one is 0 1 and 2. I'll change the color. 0 1 2 means you need to go to second column and you will be able to get what will be the row and what will be the column with the number 6 only. It means it is possible to represent that in a linear fashion, right? Now, let's say if the array is this only, means from here, let's say you have given your you are given with this array, and they wanted you to search for an element that is 11. Search 11. How you'll going to do by applying binary search? You'll be doing one thing. You'll be keeping your left pointer here. You'll be keeping your right pointer here, right? Means right pointer is at 7th index and the left pointer is at 0th index. Now, what will be the mid? Mid will be 0 plus 7 by 2. What will be the mid? Now, 3 will be mid, right? If 3 will be mid, you are searching element which is 11. Now, that is greater than that 7. How you are going to check? Means you have mid is equal to 3, but you don't know. Means what is the element present over there, right? So, what you can do? Mid divided by uh, this n, right? And mid mod n. This will be equal to row, this will be equal to column. Now what will be the row? 3 by 4 is 0, and 3 mod 4 is 3. It means row will be 0, column will be 3. Go to row. Now you need to check, like, let's say matrix of r comma c is greater greater than what? Your target, right? Then what you need to do? You need to perform, like, you need to move your left pointer to mid index plus 1. That you need to do. Till that point is clear. Now we'll be solving further. Now your search space will be like from 7, that will be ending here. Now 10, 11, 16, 20. What are the indexes? It starts from 3, right? 3, 4, 5, 6, 7. Now your left, your mid was here, and you'll be moving your mid, that will be here. Now your left pointer is here, right pointer is here. What next? You need to calculate mid again, right? Now 7 plus 4 index by 2 means 11 by 2 will be your 5. You are going to check if mat of r comma c. How we are going to calculate r comma c is clear, right? Means you can follow this code and you'll be able to calculate what are row and what are column. Now if you have row and column, what we need to do? We need to check if that is less than or equal. We'll see. Okay, target. If less than target, then we are going to move our right pointer to, means, mid minus 1. But if it is equal, can we move our right pointer to mid only? Yes, because instead of moving there, we can solve this in just two conditions. Means you can move your right pointer to mid only. Move to mid. Move to mid. Okay. By moving mid, now you have two conditions. That is case 1 and case 2. With that, you'll be easily able to apply binary search. So what you need to do then? You need to keep two pointers. Like, one is left pointer, left will be at 0, and right pointer. Right pointer will be at m cross n minus 1, right? Now, while left pointer is less than right pointer, you need to run your algorithm. What you need to do? You need to check for mid. What will be the mid? Left plus right by 2. That will be mid. Now, what you need to do? You need to calculate row and column, right? What will be the row and column? Row will be mid index divided by n, comma, mid will be mid mod n will be column. Now you have what is the row and what is the column. Now what to check? If mat of row and column is less than target, what you need to do? You need to move your pointer. Which pointer? Left pointer. Left pointer to where? Mid plus 1. Let's check if we are doing correct or not. Means Okay, just check if this point is greater. Oh, sorry. What you need to do, if this one is smaller and this one is greater or equal. If you are somewhere here and you wanted to move to, yeah, your target is smaller, means you need to move this direction. If your target is greater, then you need to move, means target is greater, then you need to move toward right direction. Okay, so that is the case. Now if target is greater, then what you need to do, you need to move your left pointer to rightward, else you need to move to right pointer to mid index, means you need to move your right pointer to left hand side. So at the end, the position where left and right will collide will give you answer, means converting that into row column and at the end checking if that element is equal to target or not will give us answer. Okay, so let's quickly implement that out and see if this algorithm is correct or not. Okay, so I'll be moving back here. Now what we need to implement it. Left pointer we need, right pointer we need. Left will be at 0, right will be at m cross n minus 1, right? Now what is m cross n? M comma n is equal to len of matrix. What is the matrix? This one is matrix, right? We put it matrix means number of rows will be assigned. What next? We need len of matrix of 0. Can we do matrix of 0? Means if column value is not 0, then only we can place this code, else it will throw us error. So you can check m and r row and column, and the m and n lies between 1 to 100, so it will never be 0. That is fine. Okay, now what next? Now while left pointer is less than right pointer, right, what you need to do, you need to calculate mid pointer will be left plus right by 2, right? That is correct. Now what you need to calculate, you need row and column value. What will be row? Mid by n and mid mod n, that is row and column. Now what we need to check, if matrix of row and column, row, sorry, r and column is less than target. If that's the case, then we need to move our, means we are at index and target is on the right hand side, means you need to move left pointer toward that direction, right? So you can keep left as mid plus 1. What else? Else you need to do, you need to move your right pointer. Where you need to move your right pointer? That is at mid index, because that could be your solution. And the place where left and right will collide will be the possible position for your target. Means at that position, either your target will be present or not present. So how you are going to check that out? Now you need to know what row and column our left pointer actually stopped. Okay, so to calculate that, you need to do this math again. That is, you need to divide left pointer by n and left pointer mod n. You got row and column. Now what you need to check, you just have to return like matrix of row and column is equal to target value or not. If it is equal to target, it means we need to return true, else it will automatically return false, means it will be returning automatically. So that is what we wanted. Is there any problem in this code right now? Let's reiterate this. We have length of matrix, this is correct, this line is also correct. First it will compute m cross n, then minus 1. Okay, while left is less than right, we are calculating mid, and we are calculating row and column. What will be row and column? On the basis of that row and column, we are checking if that particular value at that point is less than target or not. If it is less than target, then we are going to move our left pointer rightward, else we are going to move our right pointer leftward. That is clear. Till this point it's right, and I think this code is correct and it will work in order of login of m cross n. Now what's the mistake? It's just a spelling mistake. Anything else? Target matrix. Matrix is correct, right? All good. Running it. Case is passed. Let's submit it. That's it, right? So you are Means at the end you able to learn how to apply binary search in 2D matrix. And in 2D matrix it was applicable only because you see here your array is completely sorted, like the last element was smaller than the next row first element. That's why it was possible, else it is not possible to solve this way. Okay, means for solving those questions there are other ways possible that we can explore some other time. Yeah, space complexity is order of 1. That's it for this video. See you in next video tomorrow.